and maybe throw it open to sort of discussion, because hopefully I'll you know, hopefully some people will be outraged and you know, want to interested to discuss this topic. So I first of all start with a bit of self-plagiarism. I think it was 2 years ago I gave a talk on the exams that we had during the pandemic, and the slide I stole from there, except it said the future is soon. So I changed the heading on this slide, and mostly because now AI, I also added this little AI here as well. So at the time I was sort of, I guess that talk was about something similar, and do we actually need any hand calculations in mathematics at all these days? I don't think you'll find a workplace in Australia where someone is actually doing calculations by hand. And probably even if they're doing it, you know, using a calculator, I doubt they're using a hand calculator. Maybe they'd use their phone if they were doing something simple like that. I think everything's probably done by systems, online calculators, etc. How will students be using mathematics in their careers and just generally in the world? And I think AI, you know, has thrown even more cats amongst more pigeons in the last year or so. So I guess I often think about what we want students to know, and I think we probably don't think too carefully enough about this, and I think we haven't changed what we think we want students to know for a long time, or at least only incrementally. I think maybe we need a revolution. Certainly, maybe that last comment on the slide is very sort of reminiscent of Merrin's talk this morning, because I think many students would finish university knowing that if you see x squared and someone says something that's sort of calculus related, then 2x is the answer. And it really doesn't matter why or what that means, because that's what got you the marks. And you know, I think this is something that we really must confront. So maybe I'll just now jump back many years, and I guess maybe this talk is something along the lines of, I think we're sort of starting to catch up to the 1990s now. And in 1990, Maple 5 was released. There was earlier versions of Maple, but I guess the interface in Maple 5 was a significant advance, and the people at UNSW before me, I think Rod James and Dennis Trineri and John Steele, decided that you know, computer algebra was sort of the future of mathematics, and certainly it had been around for a little while, and it was becoming more and more evident that it was a thing that was here to stay. So they introduced Maple use into the first year courses, and it was essentially a sort of bolt-on sort of thing, I suspect. That they added some things to the main algebra and calculus notes, and they wrote a set of Maple notes separately, which were called the first year computing notes. They designed a sort of auto-marked assignment that students would submit, where they had to write some Maple code to solve some sort of problems related to the rest of the content in the course. And there was a lab test. We had student labs back then. We have a little bit more larger size labs now, but mostly it's the same. And students came in to do a lab test where they solved some problems using Maple. And Maple was also in the exam, handwritten exam, but there were sort of static examples of Maple in the exam. So it was sort of meant to be throughout the course, but in some ways it wasn't really, it always was a bit on the side, perhaps because lecturers weren't, so some of the lecturers didn't really embrace it. You could easily do the course with sort of ignoring that little section, that annoying Maple part, and I think many students did. So in the Maple lab test, they would sort of answer questions that were designed that you must do with Maple. So they were like this. Here's a couple of examples, things you just could not do by hand, and certainly couldn't do with the sort of calculator that you had from school. So they would have to answer these questions. They would make a Maple worksheet, which would then be printed out and hoovered up by some special software that was designed for the lab, and then printed out on lots of paper and markers with markers. And this was very it was a very well-run system. It went pretty smoothly, so everyone was learning a bit of Maple in first year. The exams, actually, these exam questions are taken from more recent exams, but they're sort of typical of the sort of things that the way Maple had made its way into paper exams. So there would be some simulated sort of Maple output or Maple session that showed some working that someone might have been doing with Maple, and then some questions asked about it. And usually a Maple that was there was something that you could interpret even if you had never seen Maple before. It was probably more a matter of not being scared to read it. And I think many students were scared. I mean, they really would avoid the Maple questions in the exam, even though if you look at this one, it's just defining a function. And then it's saying you define a new function by, from the old function. And here's a plot of the result. It doesn't really take much Maple knowledge. I mean, I think anybody who was sort of not scared to read that would probably work out what this was about, even if they'd never seen Maple before. So that was the sort of typical sort of way Maple was included in the exams. Here's another example. This was a very poorly done question. A good example of students avoiding looking at the Maple, because it's a sort of classic problem where you take a length of string and cut it into two pieces and make a circle out of one and a triangle out of the other, and what's the area and how do you maximize the total area. This is the sort of thing that you could have at high school. Students just ignored that Maple code and they worked it all out again themselves or by paper. I mean, looking at the exam scripts at the time. And so this is not totally a high school problem, because the first part, if you look at the question there, it says, by referring to appropriate theorems, explain why there must be a maximum and a minimum. It's not purely a high school question, but nevertheless, it sort of, students could get through enough marks in this without really engaging with the Maple. Here's another example. You're asked to find the inverse of A. And students would find the inverse of A by Gaussian elimination on the page, instead of trying to think about how they could use what's written there. So I guess the way in which Maple was being tested was it was a shortcut for students who knew what they were doing and could use it. And all the questions were sort of generally doable without it. So I guess shortcuts in the exam are the way you get higher marks, because then you can spend more time on other things. Another typical sort of question, the hard grunt work of doing some Gaussian elimination is done for you, so you can ask questions about the theoretical things like the nature of the solutions for certain values of a parameter. And this one was I put this field in because I really liked it, but most students didn't. But it was, I think actually, I often write exam questions thinking this will be great as a past exam question that students will learn from. And I think that's probably the case. Anyway, I won't stay on this too long, but it essentially comes from the logistic map and sort of looking at when you have there's two subsequences of even odd values in there. It's quite interesting. Anyway, Maple code was placed in there so that you could save the students from horrendous calculations. Okay, so pre-COVID, the Maple in the exams was typically of the form you've seen. It was a Maple session with some working already done, and many students just ignored it and did the question by hand in another way. So we had Maple there, and there were certainly students who appreciated it, but it wasn't well liked. Something that improved students' attitude towards Maple was when we introduced some online tutorials with Maple TA. Maple TA is now been rebranded to Merbius, but that was Maple TA back then. And essentially this helped students' use of Maple, not partly because it was actually a little bit confusing because we were teaching them how to use Maple, and there was this online system called Maple TA, and many people would be very confused and think these are the same thing. One was just like a web-based testing system, and the other was a computer algebra system. But behind Maple TA is actually Maple. And so there were lots of places in these online tutorials where we would ask for students to enter algebraic expressions in Maple syntax. And the fact that they could do this, they did this on a weekly basis. They did this in a sort of online at home, and they did it in a way where they could check their answer and repeat until they got things right. Sort of very low stakes, low stress, I guess. And so they got quite familiar with Maple syntax, and that actually really made a significant difference to the student attitude towards Maple. When UNSW switched to 3 terms, I don't know if you know, UNSW has 3 terms. Everyone at UNSW knows it's got 3 terms. It's a hot topic of hot topic of conversation, even now, many years later. When we switched to 3 terms, we changed the assessment structure in first year, and we made it so that there was a lot more. Well, the exam weight reduced down to 50%, and the stuff that the students did during the term was mostly very repeatable, and you could practice and keep working until you were sort of getting a high mark. And so the average mark students have before they go into the exam is something around, depending on the term, it varies a bit, but it's something around about 42 or 43 out of 50. So the stuff they do during the term is meant to be, you accumulate marks to show that you've really done all the work and you've been working steadily on it. So when you come to the exam, you don't need many marks to actually pass, and so the exam questions are sort of like typically much harder. During the term, one of the big components of the test of the assessment are the lab tests, and the previous Maple lab test was sort of disappeared and became combined with what were previously class tests written on paper that now became lab tests done in the lab using Maple TA. And here's a typical question, and you can see at the top we've added some advice. This question can be done without Maple, the Maple computer algebra system, but you might find it helpful. So the first lab test, we don't allow the Maple use, and that's got to be all done by just sort of hand methods. We don't even allow a calculator. The second one, we allow Maple, and students can use Maple, although some questions are harder to do with Maple than without, and some questions are easier, and some questions require it. So the students now know that in lab test 2, they absolutely have to use Maple. Well, for some questions, they absolutely have to use Maple. Other questions are a bit easier if they use Maple. And this sort of has translated into them thinking that they must use Maple for everything, which perhaps has gone a little bit further than what we wanted. But nevertheless, it does show that they sort of, are more disposed towards it. So here's a test question where Maple is actually required. We don't teach any method that will let the student actually solve this ODE by hand, so they really must use Maple. It's essential. Then you probably remember, although I've been trying to block it out now. In 2020, it was week 5 of our term 1. Well, I mean, it started earlier than that, but week 5 of our term 1, suddenly we all went online. And on, I think, Monday, we had classes as usual. Tuesday, we said, everything's cancelled. See you tomorrow online. And
yeah,
it was quite, I mean, sure, everywhere it was a huge shock. But one of the things that we had to do, of course, was decide what to do with assessments. And this, I'm sure everybody has their own experience of what happened. At UNSW in Maths and Stats, we, in first year at least, we decided that because, well, we weren't allowed to supervise the exams. We weren't allowed to instigate any sort of invigilation. That was completely forbidden. And so the exams were just online at home. And we could tell the students whatever we thought the rules should be, but we decided that telling them that they couldn't look in their notes and they couldn't use the internet and they couldn't use Maple, which they were taught throughout the course, was unrealistic. So we decided that we weren't going to ask any questions like integrate x sine x dx anymore in the exam, and we would have to design new questions. So this is sort of in the previous talk. In designing new questions, we just came up with things that we thought that you would have to understand what you were doing to answer the question, and you couldn't just simply type it into some sort of online calculator. And so there's a number of questions like that. I'm not going to sort of spend time on them, but typically, there's nothing here that you can just type into a calculator. You have to sort of look at the pictures and figure out what's going on. And I started using the word mental models after a previous talk by Merrins, and so that's in the title here. You need a good mental model to actually make any sense at all of what's going on here. We designed questions that you simply couldn't Google. You have to really sort of think about what's going on. They're not hard. This isn't a hard question. It's just that it's not something that you can just type into some calculator. After the pandemic, we sort of everyone wanted to go back to normal, but the world has changed, and we aren't going back to normal. Well, there will be a new normal. I don't know does anyone know what it is yet? Still a work in progress. So we wanted to return to invigilated exams. I mean, me in particular, I was traumatized by what happened during the pandemic with exams. So we wanted to return to invigilated exams, but the central exams unit had been disbanded and the university had decided that exams were a thing of the past. And we were allowed to run invigilated exams, but they wouldn't run them for us. And our big first year course, we have 2,000 students. So, how could we do this? Well, we have a computer lab with 190 computers, and so we decided to run multiple exam sessions with randomized exams. So, given that we decided we must run the exams in our labs, and we had from the pandemic, well, actually, UNSW having 3 terms means that we were writing 3 exams per year for these courses instead of the previous 2. So this meant we had a bigger exam bank of questions than we might otherwise have had. It's an advantage of the 3 terms. No one has actually considered, I think. So we have a larger than we might have otherwise had a bank of exam questions that were designed under the assumption that students would have access to software. It would be a pity to just throw them away. We were going to run the exams in the lab, and on those lab computers, Maple, Mathematica, MATLAB, and R are all installed, just sitting there ready to be used. We could disable them, but it just seemed like some sort of a waste, really, to sit students in front of a computer that's capable of a lot and tell them they're not allowed to use it. So we decided to allow Maple in our first year exams. Now, that's not all of the exams. We've got a first year stats course, of course, and they use R, and there's another first year course which uses MATLAB. But all of the first year courses, or bar one, it's a very small one, allow software use in the exams, and it's mostly Maple. So I guess what I would say is that before the pandemic, well, in fact, maybe before the online tutorials, Maple was definitely one of the most complained about aspects of first year courses. It was reliable. When you read the student surveys, they would say, "Why do you make us learn this useless thing? It's not maths. We're here to learn maths. Why would anyone want to use it? Get rid of it." But I guess we're very stubborn and we didn't get rid of it. But it was definitely a problem. It was definitely a problem. We tried lots of things over the years to sort of ease the way in, make things a bit more a lot more formative stuff and resources for the Maple, but it still wasn't very well liked. And I was looking for comments in the recent student surveys about Maple, and I would say the only negative comments, maybe not only, but the majority of negative comments were just about the fact that Maple, the students mostly use Maple at home via a Citrix server that the Central University runs, and that can be unreliable, particularly if you've got dodgy internet at home, because for Citrix you need to it's a web-based thing. Most of the comments were about that, but there were quite a lot of positive comments, and I just, in order to prove my point by selectively picking one really nice comment, it's here. So this student loved the use of Maple software, and they thought it helped their conceptual understanding and stopped them wasting time on tedious things. Students now largely embrace Maple. I've seen, I read the Reddit subreddit for UNSW, and there's often students saying things like, "Maple is your friend. Make sure you learn how to use Maple." Anyway, I think this sort of really is all about what mathematical skills do students need, and I'm sure there were lots of people have lots of opinions on this, and I could easily argue about this. Are hand calculations used in current workplaces? I don't think so. I think we all prefer understanding versus calculation as a sort of end goal in what we teach the students. And of course, it's clear that that you really do need to do some calculations in the nitty-gritty to sort of get an idea of what's really going on behind. You couldn't avoid that completely, and you do probably need to do a certain amount of repetition so you become familiar with it. So this argument tends to always bifurcate into those who think the other side is saying you should never do any you should never do anything boring, and one side that thinks the other side thinks that you must only ever do boring things. And of course, it's a matter of finding the right balance. And I think that even one thing is being talked about a lot recently is AI, and I think that that and just general software systems available now probably changes what the optimal balance should be, and I think that's something we need to think about. And I think we're definitely going to be asked to justify justify what we teach to students, given that software and AI can do everything that we currently teach the students, I think. So if I stop there, have I avoided any koalas? I'm not sure.